last video, we talked about ratios, and I gave you a hint as to what trigonometry would be about. So here we have a right triangle, yes? Right triangle. It has angles alpha, beta, and 90 degrees. Now, just to start off, let's get this settled. If this is 90 degrees, right, 180 degrees in a triangle, there are 180 degrees in every triangle, is equal to that 90, because it's a 90 triangle, right? Right triangle, 90, plus A plus B, or beta, alpha and beta are more commonly used, which means that just algebraically, 90 is equal to A plus B. And so A is equal to 90 minus B, and the other way around. So just to get that out of the way, this is to say that we only need to know one angle. If we know one angle, we can solve for all of them. So let's say we only know A. Let's say we know this angle A here. So what is the sine of A? The sine of A, as we learned from SOHCAHTOA, sine of alpha, is equal to the opposite over the hypotenuse. The cosine of A, right, cosine of alpha, is adjacent over hypotenuse. And lastly, the tangent of alpha is equal to the op over the hype. Opposite over hypotenuse. This is our hypotenuse, the longest side here on a right triangle. All right, so how is this useful at all? Well, for one, if A is known, all of these things are constants here. Sine, cosine, and tangent of alpha, they're all constants. They're just ratios within the triangle. The cosine, as we've learned, is the ratio of the adjacent to the hypotenuse. The sine is the ratio of the opposite to the hypotenuse. And the tangent is the ratio of the opposite to the adjacent. So they're all constant ratios. If we drew the same triangle with the same angles, we would not suddenly have different ratios to the sides. Like, really, similar. The ratios to the sides are constant. All right, I'm just going to erase that. But what can we do with this? So these are all constants, and they're equal to adjacent over hypotenuse, opposite over adjacent, and opposite over hypotenuse. So just with this alone, we can't find anything out about the values of the adjacent, hypotenuse, or opposite. But if we were to be given one, could we? Let's see. If, let's say, opposite is equal to some k. So that would mean the sine of A, right, alpha, would be equal to k over hypotenuse. Now we only have one variable here, or one unknown, not even a variable. So we can just solve it, right? So that would mean, I'm just going to go a little bit fast here, but you can figure it out on your own. That would be equal to k over sine of alpha, which is a constant. So that's really useful. We knew one, and now we're able to find another one. So we knew the opposite, and we could find the hypotenuse. And that goes the same for any. Let's say we know the hypotenuse. Let's say the hypotenuse is equal to c, generic constants. So what is the opposite equal to? Well, the opposite to the adjacent, the ratio is sine of alpha. And sine of alpha is a constant. So sine of alpha is equal to the ratio of the opposite to the hypotenuse, c, then opposite is a barking dog. No, opposite is c times the sine of alpha, and that is a constant. So that's very useful. This is what trigonometry is for. It is for finding the value of sides in right triangles when we know a single side and an angle. And it is very, very simple. It's just ratios and a little geometry, and I think it's going to be a lot of fun. Thanks for watching.